All right, so the average value of an integral. It's also called the mean value theorem. It's just 1 over b minus a of f of x dx. So all that 1 minus ba is it's a constant that's getting multiplied by outside of the integral. So if I'm asking you to find the average, value of f of x, over the interval from 1 to 3. So it's really important with this interval must always be closed. It has to be a closed interval, and f of x must be continuous over that particular region, or you can't use any portion. That's part of the fundamental theorem of calculus. It's you can't find the area if the under a curve if their area of if the function is not continuous or there's breaks in the function, and you must include the endpoints of that interval. All right, so to set this up, I just need to take the integral the interval must be closed. So for example, if for any reason it was something like 1 to 3, you see how those parentheses around that interval? You wouldn't be able to do that because that would be an open interval. I doubt you would see that, but it's just one of those conditions that you have to say it has to be a closed interval, which means that 1 and 3 must be included. Thank you. Let me see if I can. Thanks for letting me know. I guess Sammy's mic's not working. Yeah, when I do it this way, I don't see the chat box anymore. So now, how am I going to do this integral? Can I do it the way I have it written? Yeah, you have to. Now, and the other thing that I have to do is I have to do that average value function, right? So then outside that integral, because I want to find the average value, on the outside, this needs to be 1 over 3 minus 1. And that's only because they want to know what the average is between that. So if I go through and then distribute this, this is just going to become 1/2 times the integral from 3 to 1. And that becomes 4x squared plus 4. And each of those go underneath x squared. Now I can go through and I have all of the information that I need to do the integration. And I'm going to write that x to the negative 2 power. All right, so the 1/2 stays out. Now, I'm putting this in brackets here because at the end of this, I have to remember I have to evaluate it from 3 to 1, which means I'm plugging that value in for x when I'm done. So when I take the integral of 4, and again, it kind of helps to think about what this would be because the integral just means the antiderivative, right? So d dx of something has to equal 4. So the derivative of what would equal 4? Yeah, it's 4x. So that's why that first piece here is 4x. Same thing here. What would the derivative, what possible piece, the derivative of something would have to equal 4x squared? It would be negative 1. Yep, it would be. It would be 4x to the negative 1 because you subtract 1, correct? And then you would be dividing by negative 1. So this goes ahead and gives you a negative 4x to the negative 1. Because the negatives would have to cancel out. If it was, all right, so if I did, what would be the derivative over here? I would have negative 4x to the negative 1. The derivative tells me to do what? It tells me to subtract 1 from the exponent and then divide by what? I take this because I took that negative 1 and brought the negative 1 over. And that will, yes. Okay. Yeah, I mean, what is the power rule? It's the power rule, though, for derivative, going for the antiderivative is what the power rule says that for any, hold on, I'm going to go ahead and move this over here for a second. So if I go back, now what these numbers on the outside piece here mean, it means now I plug in 3, 4x, and then I go ahead and subtract 1 for x. Now, I don't have a constant of integration here, right? Why do I not have a constant of integration? So whenever you have a definite integral, you don't need the constant of integration because by taking this one portion, let's say even if there was, let's say there was a c here, right? I'll just go ahead and do it like this so you can see what would happen. If there was a c, that 1/2 would stay here. I go through and plug this in. That would be 4 times 3 minus 4 times 3 to the negative 1 plus my constant. Yeah, the c just cancels out, right? And then right, because on the other side, when I do the same thing, now I'm plugging in for 1, it would be 4 times 1 minus 4 times x to the, oops, not x. 4 times 1, and that would just be minus, right? After I go through and distribute that negative and I subtract those two, those c's would always, doesn't matter what they are, those two c's would always cancel out. So whenever you have definite integrals, you don't need the constant of integration. So this to me would be kind of a question that I would ask you if I was trying to go ahead and give an oral exam. A question could be something like, if I take the integral of f of x, that's an indefinite integral, versus the integral of a function that is a definite integral, why does one need a constant integration and one does not? Right? Something to explain that you understand a concept. All right, so I do all of this math. Let's see what we get. That 1/2 is just going to stay out front until I get all of that done. That goes ahead and gives me 12 minus 4/3 minus 4. And over here, all of this just becomes plus 4. Okay, because inside here, that is 4 times 4 times 1 to the negative 1, which is 4 minus 4 over 1. So those two 4s change signs. One of them was negative, one of them is positive. And then I am left with 1/2 times 32 over 2, or 16 over 30. Oops, that's 32 over 3, excuse me. The general power rule for any f of x to the n dx tells us to do what? It's x all divided by n plus 1. So if I had for x to the negative 2, that equals 4x that's negative 2 plus 1 divided by negative 2 plus 1, which is my 4x to the negative 1 over negative 1.